Hello, so today I'll be presenting my temperature activated fan. My name is Alexander Ramirez and I worked alone on this project. So I'm going to start with my PERT chart. I began my process by brainstorming some ideas. A fan activated by a set temperature immediately stuck out to me as I had a hunch it would be doable for one person. Plus I had personal reasons for making one. I live upstairs and it is cut off from the air conditioning to the rest of the house. Plus it tends to run hotter than the rest of the house because heat rises and my room is the only one upstairs. The idea of making a fan for myself that I can direct in my direction when my room gets too hot was appealing to me. This led to the research where I looked into different ways I could make this fan. I found a couple that used the thermistor and a few that used the TMP36 temperature sensor. I ended up going with the TMP36 because the code for it looked relatively simple and there was plenty of places I could get references for the code. I did some more research and looked into several videos to put me in the right direction and help me find the materials I needed. And once I got everything, I began to work on building it. This is my Gantt chart. It basically repeats everything I talked about from the PERT chart. My building, testing, and debugging all occurred at the same time because once I built it, I had to go back and see what went wrong and fix it. And then eventually, over last weekend, I was able to fix all the issues and bugs and got it working. This is my purchasing report, and here are a few of the main components. The first in the top left is the TMP36 that I mentioned before. It is the main component used for sensing and telling the temperature to the fan and telling the fan whether it needs to turn on or not. To the right of that is the Arduino board that we use for the class. I decided to pick a project that would be compatible with the Arduino because so I didn't need to buy more parts than needed. On the bottom left is the fan I used to connect the circuit and provide the cooling. And to the right is a L298N motor driver, which is used to send power to the fan when the temperature reaches a certain point. So the problem I'm trying to solve is overheating. I know from personal experience and from my surveys, especially during these hot summer months, many people look for relief from the heat. However, this search for a solution to counter the heat can lead to many people using fans, but regular fans do not turn off when you are done with them. They keep running and wasting electricity, even when they may no longer be needed, just because you may have forgotten to turn off the fan. So my solution to this is a temperature activated fan. It turns on and off at preset temperatures, and you can have it flick on the moment the temperature increases out of your comfort zone. And as the cool of night comes, the fan will sense the changes in temperature and flick itself off, not wasting any more electricity than needed. As you can see in the picture, there are 3 LEDs connected to the fan, programmed to flick on and off as the temperature rises and falls. Red means that it's too hot, the atmosphere is too hot, and it triggers the fan to turn on. Yellow means that the temperature is close to being too high, but it does not trigger the fan yet. And the green is shows that the temperature is good. Okay. Next, I'll be going over my theory. I'll be talking about how the TMP36 actually works. The other option I had was a thermistor, which contained a temperature-sensitive resistor that would control the voltage going to the fan. The TMP36, however, uses the property of diodes to sense the temperature. As the temperature in the surrounding air increases, the voltage of the diode is told to increase at a known rate. It precisely amplifies the voltage and easily generates an analog signal that is directly proportional to the temperature. And there's the equation for that in the bottom. Okay, so here's my surveys for the, I picked out 2 questions to add to my presentation because I felt like these 2 were some of the more relevant ones. First question asked the surveyors if they care about how much electricity that they use, with the majority of them saying about 84% saying that they did care. The second question asked them how often they experience uncomfortable overheating, with the data being much more spread out. 13.7% said they experience it very often, 23.5% saying often, 29.4% saying somewhat often, 9.8% saying fairly often, and 23.5% saying not often at all. And so when analyzing these surveys, I came to the conclusion that the majority of people did not care, or did care about their electricity consumption. This is because the more electricity used, the more people have to pay for it. Therefore showing that a fan that is able to save you money on electricity by turning on only when it is needed may be of interest to the majority of people. My second conclusion that I came to was, even though the results were a little bit more spread out, the majority of people did experience some level of overheating, claiming they usually fell into often, somewhat often, often, or very often. This shows me that the fan will be of use to this group of people, as many of them may seek relief from a fan to escape the overheating. Okay, this is my code. As you can see on the far left, I began by defining a few different things. First, I defined the temperature sensor, which is analog 0 on the Arduino board. Then I defined all the different LED lights so that they are able to turn on and off when they needed to. Then I defined the different inputs that were connected to the L298N motor, which was connected to the fan. Then you can see that I set the temperature, meaning the temperature that it will not turn on, to be between 73 degrees and 74.9 degrees. And then right at 75 degrees, it senses that the temperature has gone too high, and it tells the fan to turn on. There's another part of the code. In the middle of the screen, that's where there are LED lights. That's how the LED lights turn on and off. And then here's a little demonstration of the circuit working. You can see the temperature is below 75 degrees, and right as it goes to 75 degrees, the light goes to red and the fan turns on. Okay, so some of the challenges I experienced were mainly beginner errors, because my project itself wasn't super complicated. For example, I accidentally put the temperature sensor the wrong direction on the breadboard, which messed up the circuit, and then it led to me burning my finger on it when I tried to touch it to see how it felt. The second big mistake I had involved carelessly mixing up the wires for the LEDs. It did not affect the fan, however, but it caused the LED lights to turn on at the wrong times. To fix this, I just had to rearrange the wires in the correct way. The last error that held me up for a while included two wires that connected to the motor fan, as you can see in the picture to the right. I just had to, the inputs to the fan were not labeled, so I was unsure how exactly the jumper wires needed to be plugged into it. And because I'm new, I did not realize that this was the issue for a while. And eventually I decided to start moving them around. And eventually I got the right order and the fan clicked on. Okay, so my first human factor that I considered was the fragility of all the circuitry, as you could see on one of the previous slides. I felt that because all the circuitry was pretty fragile, that there needed to be a protective shell around it to protect all of it, in case the user knocks it over or drops it or something, or they're just carelessly mishandling it. So I use electrical tape to tape down all the circuitry inside. And then I hot glued the fan in place into the cardboard so that it was all secure and safe. And the second human factor I considered was how easy is it to use, because especially like older people, like they might have difficulty turning it on and off or figuring out how it works. So all you need to do is plug in one 9-volt 1 amp power source into the Arduino, and it's on, and it'll turn on once the temperature reaches a certain point. And then here's a video of the final product working. You can see the red LED light on the inside is turned on, and then that tells the fan to turn on. Okay, thank you for listening.
Excellent job. Just doing this again by yourself. Very, very proud of you. Yeah, it takes a lot of guts to do it by yourself. Good job.
Thank you.
Yeah, great job. Yeah. I'm so proud of you guys. You're just awesome. We have next here.
Group C is going to present.
Okay.
Let me share the screen.
So I'm gonna put myself on mute. When you start sharing, I will put myself on mute and I will start. Oh, it's recording. No, no, no.